Good evening, children.
Good evening.
Good evening.
Good evening, ma'am.
Good evening. I shared 3 questions with you. We'll see the answers for those questions. Yeah, so I think this is the first one. Find the distance between the points. Yeah, we will be discuss. So today we are starting off with the chapter coordinate geometry. So I'll be giving you, a brief introduction to this chapter with respect to the different formulae we use in this chapter. The derivation of the formulae we'll do it later because I just want to get started with the questions. We'll also learn how to derive the distance formula, the section formula, and the formula to find the centroid of a triangle. So before that, so the class, before I do these derivations, I'll also check with you if all this has been taught in school. If these are omitted, we'll also omit it. If the derivations are omitted, even we'll omit it. So I'll just go with whatever you say, you people say. I'm ready to do it, but if you say that the teacher has not done it in school and, or you check with your teacher and she says it's not a part of the board exam this year, we'll not do that. So that so for that reason, I'm postponing that. Please check if we need to learn the derivation for the distance formula, section formula, the coordinates of the formula to find the coordinates of the centroid of a triangle. So we have a derivation for that. Distance formula, section formula, centroid. These 3. Area of triangle, you don't have this here. So leave that. So these 3 things, just check from your teacher if we need to learn the derivations. If yes, we will do it. Okay. Yeah, what's the answer? What is the distance between the points R and S, or the length of the line segment RS? What is the length of the line segment RS? Who wants to share the answer? Yes. Worked or no? What happened? This is no meditation class. Why is it so quiet? Nobody's worked? Please answer something. Okay. All right, then we will not see the answers. I'll give you the introduction to the chapter. I'll let you. We'll see the answer. So I'll give the introduction to the chapter. So first is the distance formula. First is the distance formula. So the distance formula is used to find the length of a line segment. Remember like that. The distance formula is used to find the distance between 2 points, which is nothing but the length of that line segment. So distance formula is used to find the distance between 2 points on the Cartesian plane, So supposing you have a point here, P, which is given by the address, say some minus 7, 10. And there is another point Q, okay, Q, which is given by the address, say 5, 9. 5, 9. So these are 2 points in the Cartesian plane. You can see their address, the 2 points P and Q with their address. Okay, so now this is the line segment joining the points P and Q. This is the line segment joining the points P and Q. Now, when you find the distance between the points P and Q, you are finding the length of the line segment PQ. Find the distance between the points P and Q. So when you find the distance between the 2 points P and Q using the distance formula, you are actually finding the length of the line segment PQ. You're finding the length of the line segment PQ. So basically, distance formula is used to find the length of a line segment. And to find the length of that line segment, you need to know the coordinates of the end points of that line segment. So here the line segment is PQ. The end points are P and Q. Here the line segment is PQ. The end points are P and Q. You know the address of P. You also know the address of Q. Only then you can use the distance formula to find the distance between P and Q or the length of the line segment PQ. So what is that you need to use the distance formula? Like, for example, to find the area of a rectangle. To find the area of the rectangle, you need to know the length of the rectangle and the breadth of the rectangle. If you know these two values, then you can find the area of the rectangle, L into B. In the same way, to find the length of this line segment PQ, using the distance formula, somebody's mic is enabled. Please disable your mic. Kanishka, kindly disable your mic, Kanishka. Kanishka, please disable your mic. Yeah. So here to find the length of the line segment PQ using the distance formula, you need to know the address of the endpoints P and Q. If you have to find the length of the line segment AB using the distance formula, you need to know the address of A and the address of B. That is, address of A meaning the X coordinate and the Y coordinate of A, XY, X comma Y. And the address of B, the X coordinate and the Y coordinate of B. Then you can find the length of the line segment, whether PQ or AB, using the distance formula. So distance formula is used to find the length of a line segment. It can be the length of the sides of the triangle, or it can be the, you can use a distance formula to find the lengths of the sides of a square, or rectangle, rhombus, parallelogram, diagonal. You can use this formula to find the length of the diagonals of any quadrilateral, and so on. Okay. So now here you should not mess like this. You must not take this as x1 and this one as x2. This is not x1, x2. So there is, every address has one x coordinate and one y coordinate. An address in the Cartesian plane has one x coordinate and one y coordinate. The x coordinate is called the abscissa and the y coordinate is called the ordinate. The x coordinate is called the abscissa. And the y coordinate of the point is called the ordinate. All right. So it's not x1, x2. It's x1, y1. Anything. You can take anything as x1, y1, meaning it's not that, P only should be x1, y1, Q only should be x2, y2, nothing like that. There's no condition. So you have two address. One should be x1, y1, the other is x2, y2. That's all. So x1, y1 and x2, y2. All right. Now after this, what is the formula? The distance formula. So see, basically when you write the distance formula, so you will write root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Units. So how many units? This is what we write. x2 minus x1 the whole square plus y square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So basically, it's under the square root we have the sum. You can see the sum here. Under the square root we have a sum. Now let's see this one. What is x2 minus x1? It's the difference between the x coordinates. x2 minus x1 whole square. We have spoken about this earlier. So when you square it, see the value of x1 minus x2 the whole square and the value of x2 minus x1 the whole square will be the same. We spoke about this in one class. For example, 3 minus 5 the whole square is the same as 5 minus 3 the whole square. 3 minus 5 the whole square is minus 2 the whole square, which is 4. 5 minus 3 the whole square is 2 square, which is also 4. 3 minus 5 is not equal to 5 minus 3, but 3 minus 5 the whole square is equal to 5 minus 3 the whole square. A minus B the whole square is equal to B minus A the whole square. So x2 minus x1 the whole square. Simply find the difference of the x coordinates. There are 2 points, no? So there are 2 x coordinates. Find the difference between the x coordinates, any order, square it, plus difference between the y coordinates. See, if you did x1, x2 there, you can do y2, y1 here. Any order, simply find the difference of the y coordinates. So there is nothing that this should come first, this should come second. Just use this rule in words. Square root of difference between abscissa, the whole square, plus difference between ordinates, the whole square. Subtract the x coordinate, square it, plus subtract the y coordinate, square it. Any order. You can also write the distance. The df is a distance formula I've written, children. Distance formula, not the length of the line segment df. There is no df here at all. You can also write it as square root of y2 minus y1 the whole square. Plus, because it's plus, no, so you can change the order also. It's plus x2 minus x1 the whole square. It can also be treated like this. You can also say square root of the difference between the ordinates, the whole square, plus the difference between the abscissa, the whole square. Any order. So you should be very quick in substituting the values. See, calculation, this chapter, the calculation is not a problem at all, because that is very simple. You just have to have that idea as to how to approach the answer. What is the procedure? That's it. Because calculation, it's very simple. It's integers. Simply find the sum or difference, square it, find the square root and stuff like that. Okay, so this is the distance formula, which is used to find the distance between 2 points or the length of a line segment in the Cartesian plane. So this is the distance formula. You don't have to write because you've already learned it in school, so you know this. So that's about the distance formula. Now the section formula. So if you want, you can make a note. Distance formula is used to find the length of a line segment. You can find the length of the sides of the triangle, or the the length of the length and the breadth of a rectangle. If you want to find the length of the rectangle, the breadth of the rectangle, you'll have to use the distance formula. If you want to find the length of the diagonals in some particular quadrilateral, you'll have to use a distance formula. So length, to find length of a line segment, you should use a distance formula. Now the section formula. Why do we use a section formula? What is a section formula? So section formula is used to find the address of a point. Section formula will help you to find the x coordinate and the y coordinate. It's not the length of any line segment here. The section formula is used to find an address in the Cartesian plane. The section formula is used to find an address in the Cartesian plane. Some point P. You want to find the address of P. That is, you want to find the x coordinate and the y coordinate of P. You can use a section formula. So for that, some specific information will be given to you. So here to find, oh, I cleared it. To use the distance formula, you need to know the, the coordinates of the ends of the line segment. So section formula, you need a specific information. We'll see what that is. But when to use a section formula? Section formula is used to find the address of a point in the Cartesian plane. There is a point P. Okay, and you want to find the address of P. You want to find the x coordinate and the y coordinate of P. Use a section formula. Distance formula will not give you that. Distance formula will not give you that. There is one point in the Cartesian plane. What is the address of that point? What is the x coordinate? What is the y coordinate of that point? To find that, you should use a section formula. Okay, that is, the very broadly saying. Now, specifically, here in our syllabus, when do we use a section formula? So you will be given a line segment, or we have only internal division. We don't have external division. See, the internal division is if a point lies on, okay, this is the line segment AB. Supposing P lies on AB like this. That means P is dividing AB internally in some particular ratio. Now, supposing you have the line segment AB like this, and when AB is produced, P lies on it. Okay, if P lies on AB produced, AB is a line segment. And if there is a point P which lies on AB produced, it means P divides AB externally in the ratio AP is to PB. AP is to PB, external division. We don't have this. External division is point P lying on AB produced. We don't have this in our syllabus. So we are going to talk only about internal division. That is, the point P lies on the line segment AB, not when produced. The point P lies on the line segment AB. So now when P lies on AB, it is dividing AB in some specific ratio. So why ratio comes here? Because when P lies on it, it's dividing it in some particular ratio. So that ratio is taken as M is to N. That ratio is taken as M is to N. Or do you take it as M1, M2, children? Is it M1, M2 or M is to N?
M is to N.
M is to N, is it?
Yes, ma'am.
Okay. Okay, so sometimes it is M1, M2. Sorry. Sorry. Okay, M is to N. All of you said sorry. M is to N. All right. So here we have to find the address of P. We have to find the address of P. That's why section formula. Okay. We have to find the address of P. So I'll call it XY. The address of A and B will be given to you. A is X1, Y1. And B is X2, Y2. That will be given to you. So we basically have a line segment. Here AB. You will know the address of A. You will know the address of B. And the ratio also will be known to you. M is to N. With all this information, you can find the address of P. So what is that you need? See, this is very important. What do you need to find P? Who's P? P is a point that lies on the line segment AB. That is, P divides AB, line segment AB, internally in the ratio. Internally in the ratio, AP is to PB. P divides AB internally in the ratio AP is to PB. P divides AB internally in the ratio M is to N. In the ratio M is to N. So when P lies on AB, automatically the ratio comes because there is one segment AP. Okay, the ratio is AP by PB. The ratio is AP by PB because AP is one segment, PB is the other segment. AP is one piece, PB is the other piece. So AP by PB is the ratio. AP by PB. AP by PB is the ratio, which is M is to N, M by N. So that ratio should be known to you. You should know the ratio. 3:2, 4:5, something will be given to you. And you should also know the address of A and B. You should know the values of X1, Y1, X2, Y2. Only then you can use a section formula. So like to find the area of a rectangle, you need the length and the breadth of the rectangle. Similarly, to use a section formula, you need the ratio and also the address of the endpoints, A and B. Then with all this information, you can find the address of P. Who's P? P is a point that lies on the line segment AB, dividing AB internally in the ratio M is to N. The ratio is also AP is to PB. So ratio should be known to you. The coordinates of the endpoints also should be known to you. Then how will you find the coordinates of P? So you can find the coordinates separately. Supposing they ask you to find only the x coordinate of P. Okay. So supposing they ask you to find only the x coordinate of P. X coordinate of P is given by the formula. Okay, is given by the formula. See here, mx2. Use only the x coordinates to find the x coordinate of P. So mx2 plus nx1 by m plus n. This is the formula used to find the x coordinate of P. So supposing you have to find only the x coordinate, they're not asking you the y coordinate, only the x coordinate. Do only this. mx2 plus nx1. See, to find the x coordinate of P, you'll only use x1 and x2. mx2, nx1, like cross multiplying. mx2 plus nx1 by m plus n. This is the formula to find the x coordinate of P. And to find the y coordinate of P, you can use this separately. It's not like you should use them together. You can use, so you can find the y coordinate of P separately. Y coordinate of P is equal to my2. So see here, m cross multiply again, my2 plus ny1. Use the y coordinates, ny1 by m plus n. So to find the x coordinate of P, use the x coordinates x1 and x2. To find the y coordinate of P, use the y coordinates y1 and y2. my2 plus ny1 by m plus n. You can work it separately also. You can find the x coordinate of P, supposing it's 2. And then you can find the y coordinate of P, supposing it is 7, minus 7 say. So the coordinates of P are 2 and minus 7. You can put them together like this later. So you can work it separately or you can work it together also. We'll see it when we solve the sums. So x coordinate of P is given by the formula mx2 plus nx1 by m plus n. And the y coordinate of, so what is P? P is the point of division. What is P? P is called the point of division. P is called the point of division. The x coordinate of the point of division is mx2 plus nx1 by m plus n. And the y coordinate of the point of division is my2 plus ny1 by m plus n. So the direct application of the section formula. See, like for example, now this area of a rectangle is equal to L into B. The direct application is when you're given the length and the breadth of a rectangle, you can find its area. L into B is equal to area. But you can also use it to find the breadth of the rectangle. When they give you the area of the rectangle and the length of the rectangle, supposing you know the area of the rectangle and the length of the rectangle, you can use this formula to find the breadth. Area is equal to L into B. So under area, you substitute area is equal to length. Under that, substitute the value into B. So you can find B is equal to area by length. So you can use this formula, area formula, also to find the length of the rectangle or the breadth of the rectangle. In the same way, the direct application of the section formula is to find the coordinates of the point of division. That's the direct application, but it can also be used to find the ratio. What are the other things? You can use a section formula to find the ratio ms to n. For that, some specific information will be given of these only. These are the only things in the section formula. That is a x1 y1, the other point b x2 y2, then the point of division x comma y and the ratio. So basically here there are three coordinates a, b, the endpoints a and b, then the point of division p and the ratio. So when you think of section formula, this should come to your mind. So section formula, yeah, line segment, endpoints, address should be there. Then p, then the address of p, ratio ms to n. So this is about the section formula. So sometimes information will be given, some information will be given to you, and you will be asked to find the ratio. So for that also, to find the ratio also, you should use a section formula. You cannot use a distance formula. Distance formula is only used to find the length of a line segment, nothing else. You cannot find coordinates. You cannot find the x coordinate or the y coordinate using the distance formula. section formula, you cannot find the length of any line segment. Section formula will only give you the direct application is you'll find the x coordinate and the y coordinate of the point of division. You can also use it to find the ratio. You can find the ratio m is to n. To find the ratio, you should use a section formula. Okay. So the terms here are point of division, internal division. This is internal division. The ratio is not BP by AP. No, the ratio is not BP by AP. This is wrong. The ratio is AP by PB. AP by PB is a ratio. PB by AP is not the ratio. Any questions here, children? Okay. So I told you section formula you can use to the direct application is to find the coordinates of the point of division. You can also use it to find the ratio. You can also use it to find the coordinates of the endpoints. So we'll see all that in a question. So given the ratio, and if you're given the coordinates of the point of division, then you can find the coordinates of the endpoints also. So section formula, you can find the ratio, you can find the coordinates of any point. So for such things, we use a section formula to find ratio or to find x coordinate, y coordinate. We use a section formula. Distance formula is only to find the length. Okay. Then an extension of the section formula is a midpoint formula. An extension of the section formula is a midpoint formula. So see, this also we'll see when we derive the formula. But the section formula, sorry, the midpoint formula is an extension of the section formula. So let me write midpoint formula, midpoint formula. So midpoint formula, basically the ratio m is to n is 1 is to 1. M is to n is 1 is to 1. So line segment AB and P lies in the midpoint. P is the midpoint. So P divides AB into two equal halves. P is the midpoint of AB. Now, I should tell you children get confused with this term midpoint and equidistant. So I'll clarify this. Midpoint and equidistant. They are two different things. Equidistant is not the same as midpoint. Okay, let me tell you now. So in this chapter, we will also come across, information where these words are used, midpoint and equidistant. When, when the term equidistant is used, the 3 points need not be collinear. Like, for example, there can be P here, there can be a point A here, there can be a point B somewhere here. Now, when I say that the distance PA is equal to the distance PB, see, a P is a point, A is a point. Okay, so what is PA? PA is the distance between the points P and A. And what is PB? It's the distance between the points P and B. PA is the distance. Say this is your house, P, this is your house. This is A, one of your friend's house, B, another friend's house. So if you walk from your house to your friend's house, PA, say it's 5 kilometers. PB is also 5 kilometers. The distance between your house and the other friend's house is also 5 kilometers. That means PA is equal to PB. The distance PA is equal to the distance PB. That means P, your house is equidistant from A and B. Your house is equidistant from A and B. So here P is at equal distances from A and B. So we say P is equidistant from A and B. So if P is equidistant from A and B, the points P, A and B they're not collinear. They don't lie on the same straight line. They need not lie on the same straight line. But when we say midpoint, P is the midpoint. See here, P is the midpoint of AB. That means A, P, and B are collinear points. When we say midpoint, midpoint means here when we say P is the midpoint of AB, P lies on AB. P lies on AB. And P lies exactly half the way. P lies exactly half the way between A and B. So midpoint means the 3 points are collinear. But when we say equidistant, you cannot assume that they are collinear. So this is what it is. When it's given that P is equidistant from A and B, this is how we draw. PA is equal to PB like this. They need not be collinear. So like this we draw. So get the difference between midpoint and equidistant. Midpoint is here. P is the midpoint of AB. Equidistant is here. P is equidistant from A and B. So that means the condition is PA is equal to PB. Here the condition is PA. The distance PA is equal to the distance PB. Distance formula, not section formula here. What is the condition? PA, the distance PA, 5 kilometers, is equal to the distance PB, 5 kilometers. So you should use this condition in work, that's all. Here that first line is important. Once you write that, then just substitute and get the answer. It's very easy. Working is very easy. So PA is equal to PB means the distance PA. What is PA? It's the length of the line segment PA. What is PB? It's the length of the line segment PB. So PA is equal to PB means the distance or the length of the line segment PA is equal to the length of the line segment PB. Distance PA is equal to distance PB, distance formula. No section formula here. And here it is not that P divides AB in some ratio. AB is not a line set. P does not lie on AB at all. If P divides AB in a particular ratio, P should lie on AB. If P divides AB in a specific ratio, then P, A and B are collinear points. So like here, like this it should be. In this figure, P is not dividing AB in any ratio. That question is not applicable at all to this situation. So here you can say that P divides AB in the ratio 1:1. P divides AB in the ratio 1:1 because P is the midpoint of AB. So the ratio is 1:1. Why 1:1? Because AP is equal to PB. AP is equal to PB. AP is equal to PB. That means if you bring this for division, AP by PB is equal to 1/1. AP by PB is equal to 1/1. AP by PB. So, okay, supposing 10 centimeters. This is also 10 centimeters. What's the ratio? 1:1. 10 by 10, 1:1. Okay, now talking about the midpoint formula. Midpoint formula is an extension of the section formula. Okay, where the ratio is, the ratio m:1 is 1:1. So what is the section formula? mx2 plus nx1. Okay. A, B, P lies on AB and it divides AB in the ratio 1:1. The ratio is 1:1. Okay, so you know this one. You know this. Supposing 4 and 5. And you know this one, something like 10 and 12. Okay. And P divides AB in the ratio 1:1. So we have all that information which is related to section formula. Ratio is 1:1. You have the coordinates of A and B. Now if you have to find the coordinates of P, you can use a section formula. You can use a section formula. Which is the midpoint formula. All right. So the x coordinate, in this case, the x coordinate of P is equal to, what is it? It's actually mx2 plus nx1 by m plus n, correct? Yes or no? Please answering. Am I audible? Class, use the emoji, raise your hand. Tarun, Murali, Hitesh, Sashmin, Kanishka, Priyanka, Harini, Sneha, Nandini, Murali, Rajarajeshwari. Very good. All right. Yeah. So mx2 plus nx1 by m plus n will give you the x coordinate of P. But what is the ratio? 1:1. So 1 into x2 plus 1 into x1, because m is to n. M is one part, n is also one part. So m is 1 into x2 plus n is also 1 into x1 by m plus n, 1 plus 1. So you get x1 plus x2 by 2. See, this is x2, 1 into x2, 1 into x1. So x1 plus x2, x1 plus x2 by 2. This is the x coordinate of P, the midpoint P, x1 plus x2 by 2. If it is not the midpoint, what is the x coordinate? mx2 plus nx1 by m plus n. If it's not the midpoint, if it is in some ratio 2:3, then the x coordinate of the point of division is mx2 plus nx1 by m plus n. But here it is, the ratio is 1:1. Now, in this case, the x coordinate of the point of division is x1 plus x2 by 2. You can see that. Similarly, how do you find the y coordinate of the point of division? Y coordinate of the point of division. So it is my2 plus ny1 by m plus n. This is the formula. But the ratio is 1:1 because here P is the midpoint of AB. So 1 into y2 plus 1 into y1 by m plus n, 1 plus 1. So you get y1 plus y2 by 2. So the y coordinate of P is y1 plus y2 by 2. You can find it separately. X coordinate of P is x1 plus x2 by 2. Y coordinate of P is y1 plus y2 by 2, wherein P is the midpoint of AB. P divides AB internally in the ratio 1:1. Is it fine, children? So here to find the coordinates of P, you can work like this. Coordinates of P are, you can work it like this, are. So 4 plus 10 by 2. Add the x coordinates. What is x1 plus x2? The endpoints are x. Endpoints you must take. Endpoints. So x1 plus x2, 4 plus 10 by 2, 5 plus 12 by 2, that's all. So 14 by 2, this one is 7, and 17 by 2, which is 8.5. So this is the address of P in the Cartesian plane. If you want to make a note of something, I'll just wait for some time. All right, children. Can I clear the slide? No response. Okay, so that's about the section formula. All right. Now, about the coordinates of the centroid of a triangle. Now, who can tell me what is a centroid? What is a centroid? So it's the point of it's the point of concurrence of the three medians of a triangle. So triangle, midpoint, midpoint, midpoint. What is a median? It's a line segment from the vertex to the midpoint of the opposite side. A median is a line segment from the vertex to the midpoint of the opposite side. So from this vertex to the midpoint of the opposite side, from this vertex to the midpoint of the opposite side, from this vertex to the midpoint of the opposite side, from this vertex to the midpoint of the opposite side. The medians of a triangle are concurrent. They will go through the same point, and that is given by the letter G. G. G is a letter used to denote the centroid of a triangle. The medians, they don't bisect the angles. The medians need not bisect the angles. The median bisects the opposite side. The median divides the opposite side. So that means this is the midpoint. This is the midpoint of this side. This is the midpoint of this side. And this is the midpoint of this side because they're the medians. Where does the median land? Where does the median land? The median lands from the vertex. It lands on the midpoint of the opposite side. It will come from one vertex and it will land on one side. From the vertex, it will land on one side. And the landing point is the midpoint of that side. If it is the median. So they need not say that's the midpoint. If it is median, then this is the midpoint. This is the midpoint of this side. So this is the centroid. This point is called the centroid given by the letter G. Given by the letter G. Now the centroid divides the median in the ratio 2:1. Okay, so triangle. This is the median. This is the median. This is the median. And say the centroid lies here. Yeah, the centroid lies on all the three medians. The centroid will lie on all the three medians. That is that point lies on all the three medians. Now, if I call this triangle ABC, and this one is, let me take a bigger figure. Okay, so triangle ABC and AD is the median from A on BC. So that means D is the midpoint of BC. D is the midpoint of BC. Now the centroid lies here on the median AD. Now the ratio AG is to GD is 2:1. Or you can say the ratio AG by GD. AG by GD is 2:1. It is AG by GD, not GD by AG. GD by AG is 1:2. From the vertex to the centroid, 2 parts. From the centroid to the midpoint, 1 part. From the, okay, AD is the median. D is the midpoint of BC. The centroid G will lie on all the three medians. So the centroid G lies on AD. So that means you can use a section formula here because G lies on AD. G divides AD in some specific ratio. The point G, which is a centroid, it lies on the line segment AD. Median is a line segment. The point G lies on AD. So then G divides AD in some ratio. That ratio is fixed. It's 2:1. However big or small the triangle is, irrespective of the size of the triangle, the centroid divides each median in the ratio 2:1. So here you can use a section formula because see you have a line segment AD and you definitely have the address of A and address of D. Ratio is 2:1. So you can find the coordinates of the centroid using the section formula. Using the section formula, you can find the coordinates of the centroid. That is, supposing you don't know, you know only A and D. Supposing I'm just telling you, for example, you know the coordinates of A and D. You don't know the coordinates of B and C. Then you cannot use the formula x1, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. You cannot use. In that case, how do you find the centroid, the coordinates of the centroid? So you can use the coordinates of A, the coordinates of D, and the ratio 2:1 to find the coordinates of the centroid. Because what is G? G is the point of division. What is G? It's the point of division of the line segment AD. So using the section formula, you can find the coordinates of the point of division. G divides AD in the ratio AG is to GD. and AG is to GD is 2:1. From the vertex to the centroid, 2 parts. From the centroid to the midpoint, 1 part. That is the ratio. AG is to GD, 2:1. And to find the coordinates of G, you can use a section formula because G is the point of division of AD. So you can use a section formula to find the coordinates of G. And what is centroid? It's the point where the 3 medians meet. So coordinates of the centroid, G is given by x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3. See, you can make a note of all this if you want to. I am giving you time. So the coordinates of the centroid is given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. The first one is the x coordinate of G. The second one is the y coordinate of G. You don't have to work it together like this. I told you. You can find separately. X coordinate of G is equal to x1 plus x2 plus x3 by 3. Y coordinate of G is equal to y1 plus y2 plus y3 by 3. Yeah, if you want to write down something, please write down. All right. Okay, so that's about the section formula, which can be used to find the coordinates of the centroid. If you cannot use the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, you can use the section formula. The centroid divides the median in the ratio 2:1. So ratio, 2:1. And what is the centroid? It's the point of division. It is on the median. It is on the median. So it divides the median in the ratio AG is to GD, 2:1. So you know the ratio. And G is the point of division. So you can find its coordinates using the section formula. But you should know the endpoints of the median. AD is the median, right? You should know the coordinates of A and the coordinates of D. Then you can use the section formula and find the coordinates of the centroid. So that's about the section formula. And area of triangle we don't have, so not talking about that. Now, so this is all about the chapter. This is all about the chapter. Distance formula, section formula, an extension of that is the midpoint formula. Then centroid, which divides the median in the ratio 2:1, and the properties of special quadrilaterals. That you might have already, you're in 10th standard. So we have learned it in 9th standard. The properties of quadrilaterals, special quadrilaterals. So you know that, but we can just recall them now. Understanding quadrilaterals, we have this chapter, Understanding Quadrilaterals in 8th standard. So there also, it was then we were introduced to special quadrilaterals. So we'll see some special quadrilaterals now. Okay, so what we will be seeing is parallelograms and the special parallelograms. So a rhombus, rectangle, n square. So parallelogram is like the parent. Parallelogram is like the parent. And so the quadrilaterals which emerge from the parallelogram are the rhombus, rectangle, and square. So rhombus is a parallelogram, rectangle is a parallelogram, square is a parallelogram. All the properties of a parallelogram also apply to rhombus, rectangle, and square, but they have their own special properties also, which is not applicable to a parallelogram in general. All the properties of a parallelogram apply to rhombus, rectangle, and square. But square has its own special properties, which is not applicable to all the parallelograms. So these three, rhombus, rectangle, squares, are also special parallelograms. So you would have learned it like this in class 8. A quadrilateral. What is a quadrilateral? Class, lower your hands. Are you there, Tarun Murali, Tashmin and Priyanka?
Yes, ma'am.
Yes, ma'am.
Yeah, please lower your hands. Sashmin and Priyanka.
Ma'am, it's not going down, ma'am. I think there's some problem with it.
Ma'am, I know, sir.
Okay. Tarun, you there? Okay. All right, children. So to just go back, go down to standard 8, we would have learned the quadrilaterals, were introduced to us like this. So a quadrilateral is, a polygon with 4 sides. It's a closed figure. It's a polygon with 4 sides. That's a quadrilateral. Now, in a quadrilateral, so you know that a quadrilateral has 2 pairs of opposite sides. A quadrilateral has 2 pairs of opposite sides. Now, when none of the, or when both the pairs of opposite sides are not parallel, the quadrilateral is called a kite. In a kite, no pair of opposite sides is parallel in a kite. So you would have seen a kite like this. Okay, where these are the opposite sides. This side is this side and this side. These are the opposite sides. You can see when you produce them, they'll meet somewhere. When you produce them, they'll meet somewhere. These 2 sides also, see the opposite side, this one, and this one. When you produce it, they'll meet somewhere. May not be in the screen, but somewhere far away they will meet. A kite is a quadrilateral, not a parallelogram. A kite is a quadrilateral in which no pair of opposite sides is parallel. There are many other properties of a kite which we will not need in this chapter. I'm just telling you about the quadrilateral. So a kite, so you can also draw a kite like this. This is also a kite. Excuse me, I hope you understand. These sides can be long and these can be small. So this is also a kite. This is also a kite. This side is equal to this side. This side is equal to this side. The diagonals are not equal. They meet at right angles. And the smaller diagonal is bisected. The smaller diagonal is bisected. The bigger diagonal is not bisected. So the diagonals don't bisect each other. The smaller diagonal is bisected by the longer diagonal. The diagonals meet at right angles. Well, we don't use this here. So kite is a quadrilateral in which no pair of opposite sides is parallel. Then one pair, no pair of opposite sides parallel, kite. One pair of opposite sides parallel is a trapezium. A trapezium is a quadrilateral. A trapezium is a quadrilateral in which one pair, exactly one pair of opposite sides is parallel. This one is not parallel because if you produce it, see, when you produce it like this, they'll meet somewhere. You produce, they'll meet. So a trapezium is a quadrilateral in which one pair of opposite sides is parallel. This also we will not use in coordinate geometry. Now, a quadrilateral in which both the pairs of opposite sides are parallel is a parallelogram. So no pair of opposite sides parallel, kite. One pair of opposite sides parallel, trapezium. Both the pairs of opposite sides parallel, parallelogram. And in a parallelogram, we have rhombus, rectangle, and square. Rhombus is a parallelogram. Rectangle is a parallelogram. Square is a parallelogram. All properties of a parallelogram applies to rhombus, square, and rectangle. So we will be talking only about these four figures. So the property of a parallelogram, in a parallelogram, opposite sides, both the pairs of opposite sides is parallel, are parallel. Opposite sides are equal. Diagonals are not equal. Diagonals are not equal. Okay. So we'll basically be comparing a parallelogram with a rectangle and a rhombus with a square. So let me write parallelogram. So we'll be comparing a parallelogram with a rectangle. Parallelogram with a rectangle. With a rectangle. And a rhombus with a square. Rhombus with a square. Okay. In a parallelogram, all these figures opposite sides are parallel. All of them are parallelograms. In all the figures, both the pairs of opposite sides are parallel. So that is not a distinguishing property. So leave that. In a parallelogram, opposite sides are equal. Both the pairs of opposite sides are equal. Opposite sides equal. Opposite sides equal. In a rectangle also opposite sides are equal. So what's the difference? Here also opposite sides are equal. Then the difference is in a parallelogram, diagonals are unequal. Diagonals unequal. Diagonals are not equal in a parallelogram. But in a rectangle, diagonals are equal. That is the difference between a rectangle and a parallelogram. So supposing you have to, prove that a particular quadrilateral is a parallelogram and not a rectangle. Okay, a particular quadrilateral, it is a parallelogram, but it's not a rectangle. Okay, so it's enough if you remember these properties. In both parallelogram and rectangle, opposite sides are equal. Both the pairs of opposite sides are equal. But in the parallelogram, diagonals are unequal. In a rectangle, diagonals are equal. That is the difference between a parallelogram and a rectangle. There are other angular differences, but angles we are not finding here, no. There are many other properties. Angles also in a rectangle, every corner is a right angle, but in a parallelogram, it is not. But we cannot use angles here, right? We are not dealing with finding angles here. So we are not talking about those other properties. Length of diagonals, length of the sides, you can find using the distance formula. Distance formula you can use and find the length of the sides or the length of the diagonals you can find using the distance formula. No section formula here. No section formula here. You want to find the length of the side, distance formula. Length of the diagonal, if you want to find the length of the diagonal AC. So you should know the coordinates of A and the coordinates of C. Then you can find the length of the line segment AC or the diagonal AC. Only distance formula here. Okay. So if you have to prove that a quadrilateral is a parallelogram but not a rectangle, what you should do, you must find, supposing the quadrilateral is called PQRS. Supposing it's called PQRS, find PQ, find QR, find RS, and find PS. Okay, find all the four sides. See, PQ, QR, RS, and PS. So you can see that PQ, okay, let me draw it for you. PQRS. Okay, so find PQ, find QR, find RS, and find PS. Find all these four sides. Find the lengths of these four sides using the distance formula. And you will find that opposite sides are equal. So PQ and SR, maybe you get something like, 7 units. Just for example, PQ and SR, opposite sides. And maybe QR and PS, the other pair of opposite sides, you get 6 units. So opposite sides are equal. opposite sides are equal, then it's a parallelogram. In a quadrilateral, if opposite sides are equal, it is a parallelogram. That's enough. If opposite sides are equal, it is a parallelogram. So you find all the four sides and you will see that the opposite sides are equal. So it's a parallelogram. But what is the question? You must prove that it's a parallelogram, but not a rectangle. Now this parallelogram may be a rectangle. You must say that it's not a rectangle. For that, you must find additional things. You should find the length of the diagonal PR and the diagonal QS. Find the length of the diagonal PR and QS. PR and QS. You will see that they are unequal. PR and SQ, they are unequal. So you will say opposite sides are equal. So it's a parallelogram. But diagonals are unequal. So it is only a parallelogram and not a rectangle. Because if it's a rectangle, diagonals also will be equal. So that is the difference. So if the question is, prove that the quadrilateral is a parallelogram, but not a rectangle. If they ask you to prove that it's a parallelogram, simply find the sides. Simply find the sides. Don't find the diagonals. Prove that it's a parallelogram. So find the sides, find all the four sides and say that the opposite sides are equal. So it's a parallelogram, enough. If there is this additional thing, prove that it's a parallelogram and not a rectangle. Then you must find the diagonals. Then you must find the diagonals. You must show that the diagonals are unequal. So since the diagonals are unequal, it is a parallelogram and not a rectangle. Because if it's a rectangle, diagonals will be equal. Same thing in a rhombus and square. In a rhombus, all sides, not opposite, all sides are equal. Rhombus, all sides are equal. Square also, all sides are equal. All sides are equal. In a square also, all sides are equal. The difference, in a rhombus, diagonals are unequal. In a rhombus, diagonals are unequal. In a square, diagonals are equal. Diagonals are equal. So a rhombus is a parallelogram in which all the sides are equal. A square is also a parallelogram in which all the sides are equal. Then what is the difference between a rhombus and a square? In a rhombus, diagonals are unequal. In a square, diagonals are equal. That is the difference between a rhombus and a square. So supposing you'll have to prove that a quadrilateral is a rhombus, simply prove all sides, simply show that all the sides are equal. That's enough. You will be given the, the coordinates of the vertices of the rhombus. If it is ABCD, you will be given the coordinates of A, B, C, and D. So using that and the distance formula, you can find AB, BC, CD, and AD. All will have the same length. All the four line segments A, B, B, C, C, D, D, A will have the same length. So it's a rhombus because all the sides are equal. So it's a rhombus. But if that's enough. To show that it's a rhombus, simply find all the four sides. If all the four sides are equal, it is a rhombus. If you have to show that it's a rhombus and not a square, then find the diagonals. If the diagonals are unequal, it is only a rhombus. All sides are equal and the diagonals are unequal, then it's only a rhombus. If all the sides are equal and the diagonals are also equal, the diagonals need not be equal to the side. It won't be equal also. If the sides measure 10 units, diagonals also will not measure 10 units. Diagonals will measure something else. It will be longer than the sides. So when we say diagonals equal, not equal to the sides, some diagonals will have different values, but they'll be equal. So if all the sides are equal and the diagonals are equal, it is a square. So this is what it is. So you will be comparing a parallelogram and a rectangle. Opposite sides equal is a similarity. The difference is diagonals are unequal in a parallelogram, but the diagonals are equal in a rectangle. Rhombus.
I can't hear you, ma'am.
Oh my God, I'm not audible, class? Am I audible?
Yes, ma'am.
Yes, ma'am.
Yeah, Harini and Sneha, please leave the meeting and join again. See, the lobby is enabled. I don't have to admit you every time. Anytime you are facing an internet issue, simply leave the meeting and join. You will not be put in the lobby. You can directly join the meeting. Okay. Yes, children. So if you want to make a note of this. Yeah, I was telling you that the similarity between a rhombus and a square is that in both the figures, the similarity between a rhombus and a square is that in both the figures or in both the parallelograms, all the sides are equal. The difference is in a rhombus, diagonals are unequal, while in a square, the diagonals are equal. Yeah, just wait for some time, just in case you want to write something. Done, children?
Yes, ma'am.
Yeah. So I prefer to write it like this, like the way you can see it on the screen, on your screen. And it's easy to remember, no? Parallelogram, rectangle, opposite sides equal. Rhombus and square, all sides equal. Parallelogram, diagonals unequal. Rectangle, diagonals equal. Rhombus, diagonals unequal. Square, diagonals equal. Very easy to remember. So you shouldn't be referring every time. So certain things like ABCD, you should remember always. You must learn to remember always. It shouldn't be that, you know, the day before the exam, you have to revise it to recall. It should not be like that. Simple things you must practice and register it. That's it for good. Okay, so I'm clearing the slide. Then about, you know, this very important question regarding finding the, you know, the the coordinates of the midpoint or, okay, let me give you a situation. So supposing you're given, 1 second, children, let's get a valid question. Okay, so supposing you know, you're given a parallelogram with these vertices. You're given a parallelogram with these vertices. You know, let's call it A, B, C, and D. We don't know the coordinates of D. The coordinates of A are A plus B, comma A minus B. The coordinates of B are 2A plus B and 2A minus B. The coordinates of C are A minus B and A plus B. Now we need to find the coordinates of D. All right. Now it's given that ABCD is a parallelogram. It's given that ABCD is a parallelogram. ABCD is a parallelogram is given. You need to find the coordinates of the vertex D. Is that okay, children? Is the question understood? Find the coordinates of the vertex D. Now here, so register this question. When you're given the vertices, the coordinates of the vertices of the coordinates of any three vertices of a parallelogram. That parallelogram can be a rectangle, rhombus, or square also. Not only a parallelogram. You know that a rectangle, square, and rhombus are also parallelograms. So the figure can be a rectangle, it can be a square, it can be a rhombus, or a parallelogram. You can use this idea for all these figures. Because in all these figures, the diagonals bisect each other. In a rhombus, in a rectangle, in a square, in a parallelogram. Because in a parallelogram, diagonals bisect each other. So in all the others, rhombus, rectangle, square, the diagonals will bisect each other. That means both the diagonals will have the same midpoint. Excuse me. That means both the diagonals will have the same midpoint. Both the diagonals will have the same midpoint. The midpoint of AC is the same as the midpoint of BD. That is the address AC. AC is the diagonal. Its midpoint is O. So O has an address. Diagonal BD. The midpoint is O. O is only the midpoint of BD also. So the address will be the same. Sorry, just a minute. Yes, children. So the diagonals will have the same midpoint. That's what is meant by the diagonals bisect each other. Okay. So if you have to find the coordinates of D, this is the method. Don't use a distance formula. All that is going to be very tedious. Don't do all that. So for this situation, because it's a, like very common question, mostly found in most of the papers. Okay, so join. So now you know A and C. So you first join AC. You first join AC. Or you can do it together, meaning simultaneously also. Let me do that. Join BD. Okay. So this is O. O is the midpoint of AC and BD. Now, how do you find the coordinates of O? How do you find the coordinates of O? Midpoint formula. Midpoint formula. X1 plus X2 by 2. Y1 plus Y2 by 2. Okay. I'm having my throat is not, helping me. So I'm just not going to talk for some time. X1 plus X2 by 2, Y1 plus Y2 by 2, using AC, using the, coordinates of A and C. So this gets cancelled. 2A by 2, which is A, 2A by 2, which is A. And here minus B plus B gets cancelled. Again 2A by 2, which is A. So what is the address of this one? A, comma A, A, comma A. Now let us find the coordinates. Let's find the coordinates of O using B and D, using B and D. So you don't know B and D, let's call it X and Y, X comma Y. Let's find the coordinates of O using B and D. So what will you get? X coordinate 2A plus B. There you don't know. So X by 2, X1 plus X2 by 2, comma, Y1 plus Y2 by 2. Y1 is 2A minus B plus Y2 plus Y by 2. These are the coordinates of O. But we already know that the coordinates of O is equal to A, comma A. That's equal to A, comma A. We know that 2A plus B plus X. 2A plus B plus X by 2, comma, 2A minus B plus Y by 2. 2A minus B plus Y by 2. Okay, so these are the coordinates of O. But we know that it's already A, comma A. We already found the coordinates of O using AC. We already found the coordinates of O using AC. And here we are finding the coordinates of O using BD. Both will be the same. This is the same as A comma A. This is the same as A comma A. So on equate these two. 2A plus B plus X by 2 is equal to A. So 2A plus B plus X is equal to 2A. 2A on either side gets cancelled. So you're finding the value of X. X is equal to minus B. Similarly, equate these two. 2A minus B plus Y by 2 is equal to A. 2A minus B plus Y is equal to 2A. Cross multiplying gets cancelled. So you're finding the value of Y, not B. So Y is equal to B. So X is minus B, Y is B. So the coordinates of D, X comma Y is minus B. X is minus B, comma B. Y is B. So when do we use this idea? When we have to find the fourth vertex of a parallelogram. When we have to find the fourth vertex, given three vertices, to find the fourth vertex of a parallelogram, we use the midpoint formula. We use the midpoint formula. You know two vertices, you know A and C. You use A and C and find the midpoint. Sorry, use A and C. Use the coordinates of A and C and find the coordinates of O. So we got A comma A. Now find the coordinates of the same point O using B and D. Using the coordinates B and D. This is what you get. You get this one using the midpoint formula. Because O is the midpoint of AC and BD. You get this. But this and this both are the same. So equate. On equating, you can find the values of X and Y. Put them together to find the to write out the coordinates of D. We'll be doing this in the class, but if you want, you can take a screenshot now if you want to write down. Okay, let me quickly tell you the answers. Yeah, okay. So this is the answer for the first one, children. Take a screenshot. Okay, I'll send these pictures on WhatsApp. So this is the answer for the first one. 2 into root of A square plus B square. The answer, oh, I think I shared this question, right? This was the question, right?
Yes, ma'am.
Okay, fine. So that is 2B root 2 units. 2B root 2 units. I'll share the answer on WhatsApp, children. Then for this one, anybody got the answer for this one? Okay, so here this is sine alpha plus cos alpha into root of A square plus B square units. And here you'll have to prove that it's equal to Bx. You'll have to prove that Bx is equal to Ay. A is equidistant from B and C. A is equidistant from B and C. A is here, X comma Y. It's equidistant from B and C. B and C. B and C. That means you should work AB is equal to AC. You must work AB is equal to AC. How do you find AB? It's a distance formula. How do you find AC? Distance formula. So you must work AB is equal to AC. So what I do is, what I do is, so after writing the distance formula, you know that AB is equal to AC. So AB is equal to AC, meaning when you square on both the sides, AB square is equal to AC square. So you can, that square root was removed. You don't have to put that square root symbol. You don't have to put that square root symbol. Okay, so this is what is that? X2 minus X1 the whole square plus Y2 minus Y1 the whole square. X2 minus X1 the whole square, Y2 minus Y1 the whole square. Now what you do after writing this? After writing this, what you do? You take, you're transposing. What you're transposing? This one has ABX. This one also has ABX. This one has ABY. This one also has ABY. So what you do is, there is ABX, no, bring this ABX to this side. See here, minus this one. And this one is ABY. ABY. Take this ABY to the other side. Transpose accordingly. Bring this ABX to the LHS. Take this ABY to the RHS. So the signs will change. The signs will change. So that is this step, transposing. Now I've treated it as A plus B into A minus B. That is, this is like A square minus B square, which is A plus B into A minus B. Again here, A square minus B square is A plus B into A minus B. That's all. Then simplify, cancel and all that. You get this. And I've taken 2 common. Here 2 is common, so I've brought it out. Here also 2 is common, I brought it out. Then this 2 into 2B is 4B. This 2 into 2A is 4A. So 4B into A minus X. And here you have 4A into B minus Y. So 4 on either side will get cancelled. 4 and 4 will get cancelled on both the sides. So AB into BX, multiply AB and AY. So AB on either side gets cancelled and you get BX is equal to AY. You get BX is equal to AY. So you can solve it, by expanding it as it is also, children, but I think this will be more convenient. So take this ABX to the LHS, bring this ABY to the RHS. It looks like this. It'll look like this, and then use the formula A square minus B square is equal to A plus B into A minus B. So this is your A square, B square. So A plus B, A minus B. Okay, I'll send these 3 answers on WhatsApp. All right, children. So next class we'll, I have to make 2 extra classes also. So please check WhatsApp for that, for the same. I had promised that I'll make 2 extra sessions. I'll make 2 extra sessions by this month end. So it's already come. I thought I'll make it around Independence Day, but I was not able to. So what I thought is I'll make 1 class. I'll teach you. Then the other class will connect, but I'll not teach. I'll help you complete whatever I taught you. It's the same. I will make 2 classes, 2 extra classes. In 1 class, we will be learning a set of questions and answers. The other class will connect on Teams because I have to make sure that you write everything, no? So we'll connect on Teams, but I'll not be teaching you. I'll share the pictures on WhatsApp with you. I have shared the pictures on WhatsApp with you. So we'll be on Teams, but you will be doing your work at home, meaning you will be referring to those pictures and completing your classwork. And at the end of that, you will take pictures of your classwork and share it with me on WhatsApp so that I make sure that all of you have completed your classwork. So 1 class, 2 classes I have to make. 1 class I'll teach. I'll not give you time to write. The other class will connect. Pictures would have already been sent to you. So you will be making use of that and writing the notes in the class. That will be the other class. So like that, 2 classes I'll make this. Maybe if I can't do it by this month end, by the first week of September at least, I'll definitely make the 2 classes. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Good night. Good night, children.